Right, another Doppler effect. They're saying a man mounts a siren on a roof of his car. Then the siren produces a constant frequency of 600 hertz. So it means the siren is a source. So a producer frequency, then we say frequency of a source is 600 hertz. So it's important to know which one is a source, which one is a listener. He drives the car at a constant speed up and down a straight road while a stationary listener takes some readings. Okay, it means we have we need to fill in the frequency of the listener. Then here we have the velocity of the listener being 0 meters per second because there's a stationary listener. After a while, the listener obtains the following pressure versus time graph from the reading taken. Okay, this is what we have. Okay, they're saying determine the period of the detected wave. So now wave is a complete wave is here. It has this and this one, the trough and the crest, and then they are like this. Now it's a complete wave. Now looking that from here to here is 3,5. So meaning this symmetrical from here to here must add another 3,5, then it means we'll have a 7 here. Now if we add 3,5 to 7, we're going to get 10.5. Then now to here, we're going to get 14. So it means the period of this is 14 times 10 to the power minus 4 seconds. That will be the period that you will take for a detected wave. Calculate the frequency of the detected sound wave. Now, because we're still on sound wave, now we know that the frequency, given that we can calculate in two ways, we can have the frequency equals to V over the lambda. So, but here we don't have the lambda. So the other formula of frequency is F equals to 1 over T. So we have the period in seconds, so we're going to use that, say F equals to 1 over T. So calculate the frequency of the detected sound. Is the frequency heard by the listener. So we'll have the velocity of the listener now. So that will be 1 over 14 times 10 to the power minus 4 to make a complete wave. So what will be the answer then? So we'll have 1 divided by 14 times 10 to the power minus 4. So this is 714, 29 hertz. So this is the frequency of the listener, 714,29 hertz. So it shows that the car was approaching him. So now state of Doppler effect in words. So in saying that it's a change, that would be a change in observed frequency of a sound wave when the source of sound is moving relative to the listener. So last one, calculate the speed of the moving car. So according to our information, what is left? So we're also given that the speed of the the speed of the source is required, but the speed of the sound is 340 meters per second. So everything is given. So let's write it down there. So the formula say the frequency of the listener, V plus minus V of the listener over the velocity of the sound plus minus the velocity of the source multiplied by the frequency of the source. So we have the frequency of the listener as 714,29 equals to 340. We said our listener is stationary, then we have a moving source, then we have 340, then the velocity of the source multiplied by 600, which is the velocity of the sound. Now, of course, we must hear a more output approaching, then we must have a minus. Then when you do your calculations, we're going to say V of the sound, then you'll get 554,40 meters per second. So that's what we have this question.